So welcome everyone to the next lunchtime seminar talk at CFPR. And today we are hosting Fang-Yi. She's a PhD student since 2022, studying the conservation of warship oak timbers. Her research focuses on techniques that enhance the understanding of these historical timbers, contributing to the sustainable management of marine heritage. And Fang-Yi, if you would take over from here, thank you.
Okay. Hi, I'm Fang-Yi, and so my research focuses on the preservation of two important historic warships, HMS Victory and the Mary Rose. So HMS Victory is the world's oldest naval vessel still in commission, launched in 1765, and it has been dry docked in Portsmouth since 1922, and is now displayed outdoors in an open coastal environment, attracting a large number of visitors walking through it every year. And the Mary Rose is the only 16th century warships on display in the world, launched in 1511 and sank in 1545. And it was raised after 437 years under water in 1982. So after it's been raised, it was treated with polyethylene glycol, which is called PEG, is a common method that used to stabilize and preserve waterlogged wood. It will replace the water in the wood and making it dimensionally stable and preventing from shrinkage of it when it is being dried. So today this ship is now displayed in an environmental controlled museum in Portsmouth. So the both ships were constructed with a significant amount of oak timber and are vulnerable to environmental change. But their different histories, treatments, and environments present unique challenge for preservation. The main challenge of HMS Victory face in preserving includes pests, especially death watch beetles, fungi, water intrusion, uncontrolled high humidity, and climate change. On the other hand, issue of Mary Rose include the presence of irons and sulfur ions lodged inside the wood, which may potentially form harmful sulfur-based acids and pose significant threats to the wood. And also the maintenance of a stable environment for the ship requires a substantial amount of energy, which may cost a lot of budget. So therefore, this project aims to gather information about the oak timber using various techniques to determine how they have degraded and the extent of that degradation. The objective is to investigate how these various treatments, environmental conditions, and biological activity affect these oak timbers. I will then explore how these findings can enhance the current conservation management plans for both ships, identifying lessons that each vessel can learn from the other or any possible chance to work together in the future. Additionally, this project aims to visualize the preservation state of the oak timbers. This visualization will help interpret the variations in oak under different conditions, providing insights into the impacts of degradation and highlighting the importance of effective conservation treatments. It also preserves the current state that while the wood is being studied, and these visualizations are expected to be displayed to visitors, enhancing the public engagement of this work. Since the final goal of this research is to provide information for the preservation of efforts of these ships, 3D imaging will serve as a valuable resource for future conservation for future conservators, also make the data more accessible for researchers, conservators, and the public. So I will begin by introducing the first part of my project, where a series of analytical technologies were employed to study the properties of selected oak timbers, including modern oak and timber samples that are taken from both ships, which represent different conditions. And XRF with X-ray fluorescence was used to analyze the presence and distribution of inorganic elements in the wood. The mapping result, like this image, um, like these two images, is the mapping result of XRF. The color means the concentration of the selected elements, indicating to the distribution of the elements and help us to trace their possible origins. For example, the zinc here, in the first image, it was transported along the tree race from the metal parts of the ship, and the sulfur in the second image here is due to some kind of treatment painting in the past. Oh, sorry. So by combining this data with other findings, we can identify harmful elements as well as those that may contribute to preventing wood decay. And another technique is pyrolysis GCMS and FTIR, which they were used to analyze the chemical composition of the wood sample and interpret the chemical degradation that has occurred. This is a chromatography of pyrolysis GCMS, which provide information of chemical compounds, and the spectrum of FTIR provide information of chemical bonding and chemical groups. Optical microscopy and SEM, scanning electron microscopy, allowed us to observe the structure and characteristics of the wood at the microscopic level, studying the wood fibers, pores, vessels, cells, the more micro deterioration, microorganisms, and you can see that in these images, we can find out the fungal hyphae in the cell and the deposits in it, and you can clearly see the cell wall structure of it. So this is used to measure the degree of decay of the wood, as well as to the prevalence of biological activity. Each sample are scanned by micro CT to observe the internal structure over a larger area to detect any internal damage that we can't see from the surface or a special property inside wood. The CT image can display the grayscale differences that indicate to the density lost, and density lost is due to wood degradation. For example, this first image, there is some darker area and lighter area. The darker area is where they have lower density. And when it comes to a very bright spot here, it is because of the very high density inorganic elements. So you can know that there is inorganic elements in the wood. So after assessing the preservation condition of the oak timbers, the next part of this project is to create 3D models by using 3D imaging and manufacturing techniques. In addition to visualizing internal structure, 3D imaging can capture the external surface of timbers, which are often affected by environmental conditions, such as humidity, water intrusion, or physical wear. Differences in texture, surface erosion, and grain patterns can all provide valuable insights into how the wood has been impacted over time. For example, there are the two images here. On the left side show is a frame, which is part of the ship's exterior wood that has been in long-term contact with seawater and rain. And as a result, its texture differs from the wood in the two image on the right-hand side, which belongs to the ship's interior, have not been directly exposed to water erosion. And the external wood tends to show signs of surface erosions, water damage, and potentially salt infiltration, whereas the internal wood often here, like this one, does not have exposed to any rainwater leakage that tends to retains their original density and structure and have been showed because it has been shielded from such harsh environmental factors. So specific methods for modeling purpose will be selected based on our understanding of oak to identify representative sections that can explain the differences in the condition of these timbers. The aim is to determine the most effective approach for producing replicas and displaying them. Beside the CT we just mentioned, techniques such as reflectance transformation imaging and photogrammetry will be evaluated. At micro CT, we mentioned before, it is also an imaging technique that enables the creation of 3D models, which include not only the visualization of the surface, but also the internal structure of an object. Using X-ray technology, micro CT captures cross-sectional image from multiple angles to construct a comprehensive 3D representation. So it is to create 3D models of the internal structure or any interested small region without damaging the sample. And these detailed models can then be employed for further analysis and visualization, providing valuable insights into the object's condition and structural integrity. Here we have two very different wood samples. On the left, this is the wood from the Mary Rose, which has been waterlogged without undergoing PEG treatment and remains in a wet state, so it is still wet. And on the right-hand side, it is a sample from HMS Victory, which has been exposed to water leakage on the ship's side, resulting in significant surface damage. And so the differences in the condition of the two samples are clearly visible here. And for more example, the structural difference that inside the wood that is worth to show include tunnels and holes created by death watch beetles in HMS Victory samples. These holes and tunnels. Death watch beetle is a very common damage, cause very common damage in the degraded wood of HMS Victory. It usually appear on oak wood. And the other one is a Mary Rose sample, which is non-PEG treated and is naturally dried. So it appears some cracks in it, which does not appear in any other samples. It shows the damage from this kind of treatment and due to the cell collapse in the wood structure. And at the same time, it's worth noting that even within the same piece of timber, the internal structure can vary significantly. As shown in the left image, biological damage is concentrated on the side of the wood, which is also the side exposed to water intrusion. That means that the water came in from this direction and this direction. And the situation highlights the impact of external factors on the timbers by observing these variations in structure. So we can better understand how different environmental conditions, such as the moisture exposure, can lead to localized degradation, influencing the long-term stability of the wood. And for comparison, this is how modern oak looks like under CT, which has a very intact wood structure, different from that I showed before. And however, one of the drawbacks of the CT scanning, as previously mentioned, is that higher concentration of high in density in organic elements can create very bright spots that make it difficult to observe the actual structure. Lead, in particular, has a significant impact on CT imaging. And unfortunately, some of the HMS Victory timbers have historically used white pens that contain lead. So this is something that we have to consider while using CT. And reflect the RTI is a computational photography technique that captures a series of images under varying lighting conditions from a fixed camera position. These images are processed to reconstruct the object's geometry and texture. So in RTI, normal visualization, like this in this image, is generated by calculating surface normals from the image. Each normal indicates the direction a pixel on the abstract surface faces, represented by different colors corresponding to specific orientations. And this technique reveals detailed surface shapes on topography, highlighting the subtle features and contours. And normal visualization is essential for creating 3D models, as it provides the necessary data to reconstruct the object's shape. So RTI allows the visualization of fine surface details. Another advantage of this technology is its portability. Not like CT, allow the process to be conducted on the ship or inside the museum. The flexibility is not limited to the very limited sample that we can take off from the ship, but then it also make it more beneficial for future research. And photogrammetry is also a powerful technique for creating 3D models by capturing multiple images of an object from different angles. And when applied to timber, it allows us to document its surface detail and the overall structure. And because this photogrammetry is a very common technique used for large objects such as a ship, buildings, and any archaeological sites. So actually, HMS. Wait, sorry. So actually, HMS Victory has its own photogrammetry team dedicated to scanning and documenting the ship's structure. And this is how they record the whole ship, the internal structure and the outside of the ship. It's different. Yeah. So also there is another PhD student that who is studying the death watch beetles on HMS Victory. She also used photogrammetry to record her samples. This is the model of photogrammetry they made from HMS Victory. Oh, wait. Sorry. Okay. So also the Mary Rose has a project using scanned photogrammetry data of the wreck in combination with 3D digital renders. This model of the Mary Rose has been built to form up around the surviving wreck on display in the ship hull opposite. The holophane uses this is the holophane, how it looks like. And this holophane uses the strips of LED lights on four blades that turns a high speed to show holographic light image and videos that appear to be floating in the mid-air. And so although these are not specifically focused on the details of wood, but the whole ship, but it is known that photogrammetry is a widely used technique in heritage, so which plays a crucial role in the documentation and preservation. So it will be more convenient for conservators to make any follow-up research or record if needed. So this may also be a choice to record my samples. And we may also explore the use of CNC modeling and 3D printing technologies for crafting physical replicas. Using physical replicas allows audience to directly observe and feel the differences in the structure and texture of wood. And museums can permit visitors to touch these models, offering a fresh way to engage with historical timbers. And so 3D imaging technology not only enhance our understanding of the current state of preservation of oak timbers, but also opens the possibility of monitoring the future change. By creating and comparing the 3D models, conservators can track the deterioration over time, offering a proactive method for managing the ongoing preservation of historic ships like HMS Victory and the Mary Rose. So in this research, we collect vast amounts of data that aid scholars in analyzing the composition, aging process, and environmental interaction of the wood. So this data not only supports current conservation efforts, but also provides a scientific basis for future preservation strategies. And through continuously data collection and analysis, conservators can better predict the changing condition of the wood and take appropriate measures to extend the lifespan of these invaluable cultural heritage items. So furthermore, the potential of this technology extends to exhibition. In exhibition, 3D models provide a more interactive and immersive display, allowing visitors to gain a deeper understanding of the structure and preservation state of these historical vessels. Attendees can not only view the physical artifact, but also explore details through 3D visualization, enhancing the educational experience. So in summary, the functions of 3D imaging technology provide the source for our future conservation efforts. And thank you.
Thank you very much for your presentation. If anyone has any questions, please ask now.
Hi, can I ask some questions?
Yes.
So I used to be an organics conservator, but in the early 1990s, so I had to do some freeze drying of the Runnymede timbers. So they were put in a freezer and wrapped in blankets because the lid didn't fit on the freezer, and we used polyethylene glycol. So just what I was wondering is there an alternative to polyethylene glycol, and did any of your examples you didn't show whether it had been treated by PET or not? So does that make a big difference to any of the techniques that you were talking about if the wood has been treated with polyethylene glycol?
Yeah. I didn't talk about because it's like more about the result. It affects results of the first part, the adenosine result, because first of all, because most of the samples from Mary Rose are pegged, but they are different, like they are pegged and they are because the main hull of the Mary Rose is pegged by pegged to 100 and pegged to 2000, but we have another sample that with pegged 800 and pegged 4000, and we also have that samples are still wet and not pegged, and that is already dried but not pegged, and also that is this is where from Mary Rose sample and from HMS Victory sample they are all not pegged. So the main problem is because I have mentioned the chemical properties. The peg will affect the chemical properties.
Yes, that's what I was wondering.
Yeah, so we use two of the technology, pyrolysis GCMS and FTIR, because pyrolysis GCMS can separate the signal of PEG so that we can see the real signal of the wood. And FTIR is like for a complement of pyrolysis GCMS, because pyrolysis GCMS we can only this is another funding project, so I have limited sample that I can do the analyze. So FTR is for a complementation and to explain what happened in the wood, to help explain what happened in the wood. So PEG affects the PEG actually affects their chemical properties, and also for example, in the XRF, when we are finding the inorganic elements, it shows like for those are not pegged, they show more inorganic elements in it. And also, for example, there are but I'm not sure now if that is the main is because of the PEG. It still needs to be studied. And also like I showed before that there is a crack in the dried material sample, and I think that is because that it's not PEG and dried, because it's not stable enough, so the cell collapsed, so so it made cracks in it. So, and you can't see those cracks in other samples.
Okay, I would just like to say to other people is that basically all the stuff to do with conservation is that you should be able to reverse things, because in the future you might invent something that's better than the technique that's already been established. So when I was working in conservation in the 90s, PEG would be the normal thing because you could take it out in the future. And that's why I'm like going, okay, it's more than 20 years now, but you're still the PEG, you're not decided that you should remove it. It's like, no, it's there and it's doing the right job. And the only other thing I was like with the Deathwatch beetle.
Yes.
So it's still active, but do you do anything to consolidate the wood?
You mean to sorry.
Are there still Deathwatch beetles actually eating the wood, living in the wood?
Yes, actually, you mean my samples for on the ship?
On the ship.
Yes, they are. They are very hard because actually there are very limited research on Deathwatch beetles. So another PhD student that she is going to graduate, and she's also studying at HMS Victory. She is the person who studied Deathwatch beetles. This is another project, but yes, and she do have some samples that are still alive, but you can still but my samples, I think they are all dead because but you can still find they are in the wood.
Timber.
In the timbers, in the holes, that we can see them using CT, that there will be a little round thing in the holes. So yes, they are still eating on the ship, but it's only appear on HMS Victory. It doesn't appear on Mary Rose. There are they don't have many biological activity on Mary Rose, but mostly on HMS Victory.
Okay, I'll shut up now. Thank you very much.
Okay, well, thank you very much for joining us today, and thank you, Fang-Yi, for the presentation. That was super interesting.